Well, we have another question here, question 9. The question says that the sketch below represents the curve of f of x equal to x squared plus bx squared plus cx plus d. The solution of the equation f of x is equal to 0 are -2, 1, and 4. Okay. First of all, let me first write the question here. Question 9. Question 9, we have like f of x given by, as we can see, x cubed plus bx squared plus cx and plus d. Okay, and we also have like the solution, let's say the solution of the equation, which means when f of x is equal to 0, okay, are like -2, 1, and 4. Okay, first of all, let's first talk about the meaning of these the solution here. When they say the solution of a function, it means the root of the function. It means the x-intercept. Okay, so -2 is the x-intercept, 1 is the x-intercept, 4 is the x-intercept also. Remember, with a cubic function, we have a maximum of 3 intercepts. Okay, 3 x-intercepts. Now, obviously, f of x is y. X-intercept is when y equal to 0. Okay, so y equal to 0. We have these when y equal to 0. When we set f of x equal to 0, the solutions are -2, 1, and 4. So those are the x-intercepts. Now, the first question here, question 9, as you can see, the question says that calculates the value of b, c, and d. Okay, so on the right here, 9.1. 9.1, we're looking for B, we're looking for C, and we're also looking for D, the values of B, C, D. All right. The fact that in f of x here, the leading coefficient is just 1, because it's like x cubed plus bx squared plus cx plus d, and the leading coefficient here is 1. Okay, we can rewrite this as the follow. We can say the f of x will be equal to, I can put x in the bracket like that, close bracket, x in the bracket like that, close bracket, and then x there in the bracket like this. And we have like the x-intercepts, okay? -2, 1, and 4. We can write it, we can write it this way. We can place in -2 over here, but we need to be careful. When we place -2 over here, it's going to be +2 here. Just because if you have like x plus 2 equals 0, this means x is equal to -2. Okay, the -2 here is the value of x, the x-intercept. Okay, so now here we write x plus 2, and there we write x minus 1, and there x minus 4. So this is another way, okay, the intercept way of writing the same function f of x here. Now, if I expand this, okay, I will have the coefficients b, c, and d. Now, let's work it out. I will just say, okay, let's first, and right here, I'm gonna do like x times x, okay, and then x times -1, positive times x times -1. Let's first work these two, and then this will be x times x makes x squared, x times -1 makes -x, 2 times x makes positive 2x, okay, and then 2 times -1 makes -2, close brackets, and then x minus 4 there, and then this will be like we can reduce, okay, what is in the bracket here, so it's going to be like x squared. Because these and these two are like terms, we can combine it like terms. This will be plus x, and then minus 2, open bracket, x minus 4. Then we can continue, we do x squared times x, and then x squared times -4, and then x times x, x times -4, and then we can still also do these 2 times -4, and then the -2 times x as well. Now, Remember we did this in grade 9 and grade 10 when we're multiplying a polynomial. Now, x squared times x makes x cubed, and then x squared times -4 makes -4x squared. Okay, I don't need to put this bracket here. Okay, just put it over. So we do x squared times x makes x cubed. X squared times -4 makes -4x squared. X squared times x makes x times x makes positive x squared, and then x times -4 makes -4x, and -4 times x makes -2x, and then -2 times -4 makes positive 8. Now, is there any like term to combine? Let's see. Term with x squared is only 1. We don't have any other term with x squared here. So we're just gonna write over here x cubed. Okay. And then terms with x squared. Okay, we have these two terms and with x squared. So this will make -4x squared plus x squared, meaning 1x squared. That makes -3x squared. And then terms with that ends with x. They're there, and then this will be -4x minus 2x. That makes -6x, and then plus 8. Now we can write f of x as since we can say therefore f of x can be written as x cubed minus 3x squared minus 6x plus 8. Now that we know, we can write now we can write f of x in this form, and then we know from this that the value of b is -3, and the value of c is -6, and the value of d is +8. Then I can write here therefore b equal to -3, c equal to -6, and then d equal to 8. So this is the solution. Okay, we have the solution. Now the next question is question 9.2. The question says calculates the x coordinate of b, the maximum turning point of f. So we're talking about this point over here by b there. Okay, the x coordinates only, that's what they ask. Okay, of the point b is here. Remember, a point has a x and the y coordinates, so we are looking for the x coordinate only. Okay, the maximum of the function. Now you do know that the maximum of a function occurs when the derivative, the first derivative of the function equal to 0. So we can just, I can move my board over this like there. Okay, so we're like question 9.2. We're looking for excuse me, over here we're looking for the x coordinate of the point b. Okay, so now we say that it is when the first derivative, okay, equal to 0. Now we're going to differentiate this function. The function that we got over here, we did find that f of x was equal to x cubed, and then b was has the value of -3. Okay, so it's going to be like -3x squared, and then c has the value of -6, -6x, and then d was equal to 8. Now we're going to find the first derivative. F of x will be what? You know, the derivative is like each term. When you differentiate each term, let me write it. Why can I write it? When to find the derivative, it's like we're gonna differentiate each term when it is like ax to the power of n derivative in a polynomial. Okay, this is like n times a times x to the power of n minus 1. Okay, so we can work out f prime of x. This will be equal to what? So I'm going to write 3n is 3 for the first term x cubed. Okay, the exponent first, n 3. Let me write it like 3 times a, the coefficient is just 1, so 1 times x to the power of 3 minus 2 minus, okay, the following is like the n is 2, a is 3, x to the power of 2 minus 1 minus 6 here means that it has an exponent of 1 there, so this will be like 1 times 6 times x to the power of 1 minus 1, and then the derivative of any constant c is just equal to 0. So over here, the derivative of 8 is just 0. So f prime of x will be equal to what? 3x to the power of 2, okay, minus 6x, okay, and then minus 6, because I say 6 because 1 minus 1 here is 0, and then x to the power of 0 is going to be 1. So we have like negative 1 times 6 times 1 is just negative 6. So that's f prime of x. Then, according to the condition we quoted earlier, we need to set f prime of x equal to 0, okay? So we will do, let me just write it over here. F prime of x equal to 0 means like 3x squared minus 6x minus 6 equal to 0. Now, we can you notice that each term of this function is a multiple of 3, so we can divide each term by 3. I divide here by 3, and by 3 there, and then this will make what? X squared minus 2x minus 2 equal to 0. Now, to solve this, we can see if can we solve this by factorization. Okay, sometimes we have like, let's see if we can solve it by factorization. Now, I'm gonna look at the constant term here, which is -2. Okay, let me write here -2. Now, the factors of 2 are just 1 and 2. Now, I want to ask myself, how can I get a sum of this -2 here with 1 and 2? What combination can give me that? If I say 1 minus 2, it cannot give me -2. 1 plus 2, neither. -1 plus 2, -1 minus 2, no. We cannot get a sum of -2 from the factors of 2 here. So the equation here is not factorizable. In this case, what we do, we can use the quadratic formula, okay? So I can use the quadratic formula. Note that the quadratic formula is given when, okay, by following this formula, x is equal to minus b plus minus square root of b squared minus 4ac all over 2a, okay? So in this situation, a is the leading coefficient, so the coefficient of x squared is just 1. So we have like a is 1, b is -2, and then c is -2 also. So we're gonna substitute these values in the formula there in red. So it's gonna be like minus b plus minus square root of b squared minus 4a and then c all over 2a, okay? We can substitute the values of b is -2, and then -2 there, b squared minus 4a, a is just 1, and then c is -2 over 2a, a is 1. Now we can do that by the help of the calculator. I can just do it over here. So this is gonna be like, I'm gonna do a minus open brackets, oops, sorry, minus open brackets, -2, okay, close brackets, and then plus I cannot write plus minus to the calculator, so I can just do them separately. Let's work out the positive first, plus square roots of b, which is -2, b squared, okay, b squared minus 4, and then a is 1, and then c is also -2. It's also -2. We close bracket there, and then over 2a. A is just 1, okay? And then when we hit equal, and then we have the results 1 plus square root of, so we have two solutions. So the first solution, we have like x equal to 1 plus root 3, okay? Which is equivalent to let's see, if I press SD, for instance, it tells it's like 2,73. So right here, 2,73. With the other, x will be equal to, it's going to be just 1 minus root 3, okay? Which is equal to, can just, oops, sorry. I pressed the wrong button, but this one, I know this is going to be negative 0.73, okay? Because square root of 3 is like 1.73, and then 1 minus 1.73 going to be negative 0.73. So these are, now these two are, excuse me, the points where we have like the local maximum or minimum, okay, the maximum or minimum. Now let's see which one. When I look at the graph, then I have a maximum. I have a maximum here below 0. So the correct answer is the negative 0.73, because this is on the left hand side of 0, on the negative sides of the x-axis. Okay, I cannot take this 2.73 because this is on the positive side of the x-axis. So I understand from there 2.73 is the minimum, but 2.73 is the coordinate of the minimum. I'm looking for the coordinate of the maximum. The coordinate of the maximum of b, so it must be the negative 0.73. Okay, so the correct answer here is this one. So that one we can say. For the other one, we can just say not applicable. Okay. Okay, thank you. Now let's see. The next question is question 9.3. What the question says. The question 9.3. That question. The question says that determine an equation. Excuse me. For the tangent to the graph of f at x equal to -1. All right. Now I prefer to move. Okay, let's read the question again. Determine an equation for the tangent to the graph of f at x equal to -1. So let's move here. I draw. So like question 9.3. The question says we need to find the equation of the tangents, okay? We're looking for the equation. You know that the tangent is a straight line, okay? And right here, we have like the tangent, okay, which is a straight line. It's of the form mx plus c, okay? So we're looking for this equation of the tangent at x equal to -1. Now, all right, now there are some information. We need to find the gradient of the tangents. Now m here, the gradient of the tangents is the same thing as the derivative of the function f of x, okay? What else? Okay, Now let's see. Let's first find the derivative of the function f of x. So f of x here, f of x was given by x cubed, okay, minus 3x squared. We did find it earlier, minus 6x plus 8. That's f of x. So f prime of x, we did also calculate f of x, f prime of x. Previously, we did find that it was equal to 3x squared minus 6x minus 6. Okay, so now this is the derivative of the tangent line. Now the derivative at the point that f x equal to 1, negative 1 I mean, because it is said at x is equal to negative 1, then we can find that f prime of negative 1, it means wherever we have like x, we're gonna substitute by negative 1. Okay, so here f of prime of negative 1 is gonna be 3, negative 1 here, negative 1 there, and then this will be equal to negative 1 squared is just 3. It's just 1. I mean, 3 times 1 is going to be 3. So it's going to be like plus 6, because negative 6 times negative 1 makes positive 6, and then minus 6 here. So this 6 and minus 6 can just cancel out, and then we have left with this is equal to 3. F prime of negative 1 is just equal to 3. So this means that the gradient of the function is equal to 3. So we can write therefore y will be equal to, instead of me writing m is the gradient, so it's going to be 3x plus c. But now I need to find this c value. Okay, so to find the c value, I need to find a point, because it's going to be the tangent is where it touches the line at a specific point x is equal to negative 1. Now let's find f of negative 1 then. F of negative 1, to find the y value, f of negative 1 will be equal to x cubed minus 3x squared minus 6x plus 8. So f, not f prime, but f, sorry, f, I meant to say f of negative 1. F of negative 1, negative 1, negative 1, negative 1. This will be equal to negative 1 to the power of 3 is just negative 1. Negative 1 to the power of 2 is positive 1. Negative 3 times positive 1 makes negative 3. And then negative 6 times negative 1 makes positive 6. And then plus 8 there. And then this is equal to 10. So meaning when x is negative 1, y is equal to 10, because f of x is like the y value. Okay, so therefore I'm gonna say I can find c. This is how I can find c. I'll sub in 10 for y, okay, equal to 3x plus c. X is negative 1. Okay, I'm using this one. Now this will be like 10 equal to negative 3 plus c. So if I move the c, the negative 3 over, that makes 13. Okay, let's just do the step. 10 plus 3 equal to c. So 13 equal to c. Therefore, the tangent, okay, at x is equal to negative 1 will be the gradient, which is 3x, okay, plus 13. Let me go over it again. So m is the gradient, okay, of the tangent line, and then the gradient of the tangent line, the gradient of the function is just the derivative of the function. So, okay, the gradient of the tangent line is the derivative of the function f. So we have f of x here, and then this was the derivative we calculated in 9.2, and then it is at the specific point, at point x equals to negative 1. So I sub negative 1 in f prime of x to get the real value, okay, of the gradient, which is equal to 3. Now I sub 3, the value of 3 there, okay, y equal to 3x plus c. I write it over here. Now f of negative 1 then, why I do f of negative 1? Because remember a point has two coordinates, x and y coordinates, okay? The x coordinate is -1, which is given, and I need to find its y coordinates, okay? Because the tangent is where it touches the graph at a specific point. So that point must have two coordinates, x and y. Now the x coordinate is -1 given. I sub -1 in the function to find its corresponding y value, which is 10. Now I'm gonna use 10 and -1 to find c. So if I sub y for 10, 10 for y, I mean, and then x for -1 for x, I substitute it here, and then I got the value of c. Therefore, the tangent line, which is the straight line, 3x plus 13. Now the next question is question 9.4. Okay. 9.4. The question says that in the answer book, sketch the graph of f seconds, okay? F second derivative of f, we call it sometimes f seconds. F seconds of x clearly indicates the x and the y intercepts on your sketch. All right. Okay. Now, I'm gonna move my board over here. Um, 9.4. So we're looking for the graph of f second of x. Now, previously we did find that f of x was given by x cubed minus 3x squared minus 6x plus 8. Okay, and then in the previous questions we also work out f prime of x. This was given by 3x squared minus 6x minus 6. Now to find the second derivative, it's when we differentiate the first derivative one more time. Okay, still using this formula, ax n derivative, this is equal to n times a times x to the power of n minus 1. Okay, so this will be my a here is 3, my n is 2, so and then x is still going to be x, so this will be 2 times 3 times x to the power of 2 minus 1. Okay, minus over here the exponent, when you don't see any exponent, it's just 1, so this will be 1 times 6 times x to the power of 1 minus 1, and then the derivative of any constant is just 0. Okay, so that's going to be minus 0, and then the second derivative here will be 2 times 3 is 6, and then x to the power of 1. I don't need to write the power of 1, just going to say 6x, and then 1 minus 1 times -1 times 6 makes just -6, and then over here 1 minus 1 is 0, and x to the power of 0 is 1, so I can just write f second of x is just 6x minus 6, which is a straight line. This is an equation, a straight line, because it is of the form y equal to mx plus c, okay, where m is 6, okay, and then c is -6. Now I know this is straight line. To find now the straight line, what we do? We know the gradients. Okay, we need at least 2 points to find a straight line. Let's take the points, the intercept, because the question says clearly indicates all the intercepts. Okay, I'm gonna say y-intercept. Y-int means make x is equal to 0. So I wanna say like because y equal to 6x minus 6. If I make x 0, okay. This value here is just the x, it's just the y-intercept. Okay, this independent term, the constant term here of it's just the y-intercept. So here we have like the y-intercept would be it's just the point 0, -6. You have 1 point already. So x-intercept is means make y equal to 0. Okay, so this will be uh, 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 instead of me, we have like y equal to 6x minus 6, right? Instead of me writing y, I want to sub in there by 0, and then this will be 0 equal to 6x minus 6. So if I move this negative 6 over, okay, this becomes a positive 6 equal to 6x. I can divide the whole equation by 6. Okay, and then okay, I move this negative 6 over, it becomes positive 6, and I divide both sides by 6 in order to find x, and then that's going to be 1. X is just equal to 1. So therefore, it is the point 1, 0. Now we have like 2 points, 2 intercepts, x-intercept, okay, that the x-intercept, that the x-int, and that the y-intercept. With 2 points, we can draw a straight line, okay? So now let's just draw a straight line. I'm gonna draw a straight line. Um, um, Now I draw the x-axis. Now I can also draw the y-axis. Just okay. Then I can place in my points. We have like the points 0, negative 6. So I can look here. -1, -2, -3, -4, -6, -5, and -6. Let's say it's my point there, and then we have also another point 1, 1, 0. This is the point 1, 0, assuming. Okay, let's see. There we have the point 0, -6, and there we have the point 1, 0. Now we can draw the straight line, a line connecting these 2 points. Et voilà. Now I can draw my line. Here is the line connecting the 2 points. And last, we have another question here, question 9.5, the last question. Let's see, what does it say? Where's the question? 9.5, where is it? The question says that for which values of x is f of x concave upwards? Now, okay, I need to move my board, or maybe we can just do it here. Okay, it is important to note that f of x concave up if the second derivative is greater than 0. Okay, so let's see. Previously, we did find that the second derivative f seconds was equal to of x was equal to 6x minus 6. So we're gonna see if which value of x will this second derivative be more than 0. So if I move the -6 over, we have like 6x is greater than 6, and dividing both sides by 6 there, and then we get x greater than 1. So it's for x greater than 1, the second derivative will be will concave up. Thank you.